think back when we studied these rational exponents. And so if I had an expression like this, the fifth root of negative 32 to the third power, if I wanted to write it in radical form, okay, so first I write it in radical form, it would look like this. That is the radical form. Now, rational exponent form, if I wanted to do that, that's asking me to do this down here, a rational exponent, fractional exponent, it would look like this, the base, which is negative 32, and that negative 32 is being raised to the, okay, the power goes on the top, so the higher power on the top, so that would be a 3, and then the roots grow under the ground, so the roots on the bottom, so this would be negative 32 to the 3/5. So that's how we'd write it in rational exponent form, but in radical form, it's this, fifth root of negative 32 to the third power. There's really two approaches to evaluating this. If we want to evaluate it by taking the root first, so I would take the fifth root of negative 32, and then whatever I get, I would raise it to the third power. So that's how I'm thinking about it. Well, the fifth root of negative 32 is negative 2. So this really means negative 2 to the third power, and negative 2 raised to the third power would be negative 8. So my final answer is negative 8. Now if I try to do the other method, okay, that means I'm going to evaluate the power first. That means I'd have to raise negative 32 to the third power, and then take the fifth root. So I'm not going to do it that way because that just is really cumbersome. It makes a really big, a large relative value because negative 32 to the fifth or to the third power is going to be pretty significant. So it's much easier to evaluate the root first. So I'm always going to advocate for method 1. Evaluate the root first, and then whatever you get raised to the power. So let's do a little practice with writing expressions in radical form. So this is written in rational exponent form, 64 to the 1/3 power. And so if I wanted to write, I know that the radicand is going to be 64. I know that the power is on the top, so that's raised to the first power, and the root is on the bottom. So this is the cube root of 64 to the first power. And so really, since it's to the first power, I don't even need to list it. I can just write that as the cube root of 64. This next one, the radicand would be 4. And so then now the power, which is on the top, is the 5, and the root is 2. So this is actually a square root, and if it helps and you want to put the 2 out in front, you can certainly do that. But it's the square root of 4 raised to the 5th power. That's one way to write it. Now you could also write it like this. You could write it as the square root of 4 to the 5th power, put the power underneath. That's fine too. So I want you to pause the video and you try C. Write it in radical form. Remember, the powers are up high and the roots grow below. Okay, so this one could be written either one of these ways. Probably the most likely is the one I wrote first. And again, even especially to evaluate it, you definitely wouldn't want to raise 625 to the 3rd power and then have to take the 4th root. Now in this next example, we're going to go the opposite direction. So this time we're going to write expressions using rational exponents, but they're written in radical form to begin with. So when we write in exponential form or rational exponent form, we have to figure out what is the base. Well, the base is the radicand when it's written in radical form. So my base is 13. Now remember that the way they're set up is power on the top and roots on the bottom in terms of our rational exponents. So the power of this is the 4 and the root is 8. Well, it turns out that the exponent 4/8 can be reduced. It can be reduced to 1/2. So raising 13 to the 4/8 is the same as just raising 13 to the half. Let's make B a you try question. So pause the video and rewrite this one using rational exponents. Pause the video now. Well, we could rewrite that as 3 to the 15/5, which is the same as saying 3 to the 3rd. And just on the side note, if we wanted to find the value of that, that would be 27. Let's turn the page. So in this next example, we're going to apply some of the power properties that we know that we reviewed at the beginning of this trimester. And so in example A, we're multiplying two powers and they have the same base. So when you multiply and the bases are the same, we can combine them together as just one single base by adding the exponents. So we're actually going to add 7/9 and 11/9. Well, if we add fractions, we need a common denominator, which they have, and then we add the numerators. So if we add the numerators 7 and 11, we get 18, and that's 18/9. Well, that's the same as just saying 7 squared, or 49. When we divide two bases that are the same, we have to subtract the exponents. So we're going to be subtracting, because we have the same base, so our base will still be 16, but our exponent will be the difference between 3/4 and 5/4. Well, they have the same denominator, so I can subtract them, and when I subtract, they give me an exponent of -2/4. Or 16 to the -1/2. And remember, that's the same as saying 1/16 squared. I'm sorry, 1/16 to the 1/2, my fault. And since 16 to the 1/2 is the same as saying the square root of 16, and that's 4, then I really get 1/4. Actually, and technically it could also be -1/4. So those are my two possibilities. Now with C, we're raising a power to a power. When we raise a power to a power, we actually have to multiply. So we're going to be multiplying those exponents, and the base will be 64. So if we multiply the exponent of 1/2 by the third, I actually get 1/6. So we know that that's really the same as taking the 6th root. That just means taking the 6th root of 64 and raising it to the first. So the 6th root of 64 is 2, or, as we saw at the beginning of this lesson, it could also be -2, because we're taking an even root of a positive number. So my two solutions are 2 and -2. So here are some for you to try. So try the 3 you try questions, D, E, and F. And when you're done, tune back in and check your work. All right, so thanks for trying those. Check out the answers. 25, 6 or -6, and finally F is 2/3. Example 5 asks us to simplify some radical expressions. So